So let me explain a little bit more in detail about the pointer arithmetic. So let me create another file, go back to Explorer. Let's have ex3.cpp main function. Let me define an integer array. This give some value and then declare pointer p, and then address of the first element is initialized there. So now I can use p as a array name, or using pointer arithmetic I can have access to the very array like that. So p is p plus 1. If I increment 1, then it's pointing to second element there. Now, pointer arithmetic is addition and subtraction. So if I decrement the p, now it's pointing to first element in the array. It's the one. So at this moment, if I do cout p, then the 20, the first element, will be printed. Go back to terminal, compile with a G, ex3. I forgot to include IOStream. There. So compile again, run it, I get the desired result. Breakpoint, go to the debugger, run it. There. Step over, so p is initialized. Then debugger console. As we understand that, if I print the value of a p, which will be same as address of the first element there, and then if I do p plus 1, it will be same as address of the second element. At this moment, the p is pointing to the first element, but however, if I do p minus 1, it shows the address, which is 4 bytes before the first element. So it is pointing to imaginary location. That is sometimes sometimes you can utilize it, or sometimes that's cause of the error. So program crashes like that. So you have a array A defined with 5 elements. Within each element, we have 4 bytes there, like that. So here, this is a first element, and this is a first byte. So if a first byte, as we can see, addresses something 70. So this is a 70, and then just imagine there is a previous 4 bytes, which is a element of the array. So then it has a 4 bytes there. So if I do p minus 1, it gets you the address of this imaginary guy. That is a something 6c in decimal number. So pointer arithmetic is just imagining the size of p is pointing, that's a 4 bytes of integer. If you do subtraction, simply decrement that many bytes. If you add, just increment that many bytes, regardless of physically there is an actual array or not. That's one of the property in C++. Sometimes you use that, sometimes that is a cause of the error. So let me explain when it causes a problem like that. So if I do p is a p minus 1, which is the imaginary one. So if I do cout p in the L, then let's compile the program and then let's run it. It displays some value, in this case 32766. So there was something at this moment. This computer allows to read whatever is there, and there's no problem. But this is not a valid logic though, but does not program does not crash. But however, if I do something radical and then try to read it, let's read it first. Compile and run. It still reads some value. But however, now let's try to write into that at that location. So 1000 element prior to that. We want to write something, compile the program and run it. It worked okay. So sometimes it's okay, but its value is meaningless. Sometimes it's not okay. So let me make it bigger. Compile the program and then run it. I'd like to make this program crash, but somehow this works. Let me change that to plus, then compile again and run again. Finally, yeah, program crashes, something like that. So when you use the pointer outside your program area, here what I mean by program area is that the pointer is used for array A, but just manually I moved way outside the area. Then what you can see is sometimes it just runs but gives you some invalid value, but sometimes the program crashes. So that's the difficulty of using pointer, and then sometimes it causes some error which you have no idea at all. But in general, if you have a segmentation fault, a program crashes, then it is because of the pointer. You are using the pointer outside the allowed range. So that's some hint. And then one of the difficulty in C++ programmers encounter. That's why in modern languages does not allow pointer arithmetic. Just compiler limits, language limits your use of a pointer and the like.